Hello everyone. Today we are going to discuss about the cross and dot product. Now, the physical significance, we are discussing the physical significance of electromagnetic. In this, till now, we have discussed in this we have started with the electromagnetic in the very first video, that is the physical significance of electromagnetic. The first video is fundamental of microwave engineering. In this we are discuss what is the low frequency application of electromagnetic, what is high frequency, and then same video we are discussed that why we are going for the higher and higher frequency. The reason here what we discussed, that is the transmitting more information, that's why we require a more bandwidth. So these examples also we discussed in detail in that video. Then in second video, physical significance of electromagnetic, that is the spherical coordinate system. So if the spherical coordinate system is the main, so here we are going to discuss the coordinate system, the second video. And in that coordinate, these are three coordinate system we discuss in detail, and we also discuss in this video the spherical coordinate system, what is the physical significance of it, what are these angle theta and phi, that we discuss. We also discuss this spherical coordinate system in detail and the formulation. Also we discuss this numerical, that what will be the area of this strip, that also we calculated by this solution. And for the angle alpha and beta we calculated, and for the complete sphere also we calculated, and we verified this with the geometric formula. Now we are going to discuss the next part, which is the prerequisite again for the electromagnet. Now today we are going for the vector analysis. Now if you will see the vector analysis here, for the vector analysis you will have two parts. So what are these two parts? That is the cross product and the dot product. So for the vector analysis you will have these two parts, that is the cross product and dot product. Now the question here is, what is cross product and dot product? The formula you know. What is the formula for the cross product and what is the formula for the dot product? That simple formulation, if you will have any two vector, that is vector A and vector B. So these two vector dot product, you can have the vector dot product is A, magnitude of A into magnitude of B into cos theta, that is theta is the angle between these two angles. This is what we can say, it is the dot product. And cross product formulation is also we are aware, that is if you will have any two vector, then whatever the angle, instead of cos theta we take the angle is sin theta, that is cross product of this where vector A and vector B is equals to, that is magnitude of A into magnitude of B into sin theta and into the n cap. N cap is the what? Perpendicular vector to the plane of application of these two vectors. Okay, so this thing that we are aware. Now what is the physical significance? Here in this fundamental we are having a focus on the physical significance. So what is the physical significance of the cross product? So before going for the physical significance, I'll ask a simple question to you. What now if I'll take a multiplication, this is the product, the vector multiplication. Now if I will take 3 into 2, so answer you know, that is 3 into 2 is 6. But whether there is a 3.2 or 3 cross 2, no, there is no such cross product or dot product for these numerical, these numbers. Now why we require this dot product and cross product? There may be some reason. The formulation, the formulation result, these that we did so many problems based on this, and we also got the marks. But whether we have thought that why we require dot product and why we require cross product, what is the difference between these two and why we require these two separate? For the multiplication of 3 into 2, that is simple, the multiplication. But for the vector, why we require this dot product and cross product? So again we will start this with the application. So I'll start with this, that is the first is the application, that is the dot product. Now in the dot product, what we have, I have taken a simple example. What is this example? This example is a work done. This in the high school level, we have studied this work done. Now, what is the work done? Force into displacement. Now, this is F is the force and into displacement. So we have taken this example, force into displacement means force dot product of force and displacement is the work done. So what is this? So force into displacement is the work done. Now how we can take this work done? Force into displacement is the one of the work the parameter work done. Now how we can have this? So we can simply share this. I'll share with this example. Now this is what one of the object. I have this object. I kept this object here. So what I'll do, I'll apply a force on this object. So force, it will take a displacement. Okay, so if I'll put here force into displacement, it will displace from here to here. So force into displacement is the work done. Now work done is what? Is a scalar quantity or vector? So you know that work done is the scalar quantity. Work done is the scalar quantity. So here we can have this simple analogy, that is the force into displacement is work done. Now force into displacement, what we are doing this? We are doing this by a dot product. Okay. So we are taking this by the dot product. Now we'll come for the cross product. Now formula we know, so I'll not go in detail of the formula. So I'll take the another same example, force into displacement. Now, but here that is the cross product. Now force cross displacement, here you will get something different. That is the resultant is the force. Now how it is possible? So you can say force into displacement is a work done. This example we are taken. Now the another example we will take. Now what is the another example? Here you can see. This is what before going to this example, you just consider this analogy similar to the screw jack. Now what is screw jack? You people might have seen that roadside sometimes the truck tire get punctured. So what they do, they use the screw jack. Okay, what screw jack do? That they move the lever, that is the rotate the lever, and what the screw jack that get lifted the truck vertically upward. Okay, now the same example, this is what the example of the screw jack. Okay, so what I'll do, we know the screw jack. Now what analogy we are trying to explain here, that is the force into displacement. This is what the analogy we want to explain. Now what we'll do, this is the lever. The similar analogy is here. This is the lever, and you can just focus on the this upper part. Okay, so this upper part. So if I will move force, what happened? Force, it will get displaced. So force into displacement, resultant is what? You just observe, it is force into displacement. I am applying force, it get displaced. So force into displacement, resultant is what? Resultant is the force. What force? It get vertically upward. Whatever the object, if I'll put some object here, so what happened? It will get vertically, it will get lifted vertically upward. You just observe the upper part. Okay, it is coming out. It is coming out of the screw. If I'll move in a opposite direction, force into displacement. Now this displacement is what? Although it may not be the linear displacement, it is the angular displacement. So force into displacement. You observe this part. It is coming down. Okay, so it is coming down. It is coming down. So what happened? What happened in this example? Force, you are applying force and it get displaced. Force into displacement. Resultant is force, either vertically upward. If I'll put an object here, what? It will apply force vertically upward. If I'll rotate it downward in opposite direction, what? It will apply force, it will come down. So whatever the small object I'll put here, Either it will come up, you can just observe the tip, it will come up. So resultant is, here it is applying a force to this object. Okay, whatever the object I'll put. Same thing happened in the example of the screw jack. Okay, so this we are doing. So what these two example are explaining to us? So these two example, what they are explaining, that to solve any engineering problem, if you want to solve any engineering problem, now these are the two simple example. I have taken the same what work done, the force into displacement, the same parameter analogy. But if the force into displacement, if it is in this manner, that is the linear displacement. This is what force into displacement. So this is what linear displacement. Now the resultant is work done. But in this analogy, if you will apply force into displacement, same parameter, but the problems are different. This problem and this problem, both are force into displacement, but here the resultant is work done, here the resultant is force. So such two different problems are there. So what is this dot product? Why we require this? To solve the engineering problem, different engineering problems similar to this. There are so many examples, problems in the mechanical engineering, civil engineering, in every engineering, in electronics, in electrical, in electronics, telecommunication. To solve all these problems, we are using this dot product and cross product. So this is what the physical, it is called the physical significance. Sometimes we never understand that why we are doing this. Okay, so we have to understand what is the physical significance of this. Now when we will go further in the next lecture, we will utilize this dot product and cross product. And this dot product and cross product, what is the physical significance of it? Based on this, again you will have the curl, gradient, divergence. Now what is this? This is the extension of this. Now in electromagnetic engineering, in microwave engineering, in RF engineering, in antenna design and antenna wave propagation, here everywhere you are using the divergence, you are using the curl, you are using the gradient. But if you will understand this, basically what? The dot product and cross product. So simple, you just remember the two examples. This is what the dot product, force into displacement, resultant is work done, scalar quantity. This is the mathematics also you can see. Again here, the force into, again force into displacement, resultant is the vertically force. So these are the basic two analogy, that is the cross product and dot product. In the next lecture, next video, we will discuss the curl, divergence and gradient, obviously with the physical significance. So thank you very much.